Okay, we're going to work on relating standard to vertex form. So we have our standard and our vertex form. Yesterday we talked about how we can change vertex into standard form. What process was that? Anyone remember?
The distribution.
Distribution, or otherwise known as expanding. Okay? Now, today, we're going to do the reverse. We're going to turn standard form into vertex form, which is a little more tricky. It's known as completing the square. And I'm just going to draw a square. Boom. Okay? So it's known as completing the square. So this process is something you guys are going to probably have to memorize, and I'll talk to you about why we're doing certain steps in the process as we go through it. Okay? So I want you to recognize, if you guys recall when we were doing factoring in Chapter 2, we looked at perfect square trinomials. And perfect square trinomials were terms that when you factored them, the two brackets were the same. So you would write it like something like x plus 3 squared. Okay? You're going to notice that vertex form has that relationship inside of it. Okay? So the goal is we're eventually going to create a perfect square trinomial so that when we factor it, both brackets will be identical and we can write it like this. And this is our vertex form. Okay? So the very first step to this is we're going to divide only the first two terms. Okay? Just the first two terms by the a value. Now what is the a value in this question? 2. Exactly. So we're going to divide 2x squared and 16x by the value of 2. And the reason we're doing this is a common factor. Well, it might not always be a common factor, but we always want to make the x squared to have a value of 1 in front of it, right? So when we divide 2 by 2, we're going to create a 1 when doing this. So our next line will read 2 on the outside, and we'll have x squared plus 8x. And our negative 30 is kind of outside of that. We're not dividing the negative 30 by that. Okay? So, the goal or the reason we do that is to create a value that's going to have 1 here. Okay? The next step here is we're going to be dividing what is considered our new b term. So this was our original b term, but after we divided it by 2, it became 8x. So there's a little formula on the side. It looks like this. B divided by 2 squared. And this calculation we do on the side is going to help us create a perfect square trinomial. Okay? So our new b term here is 8. Okay? So we're going to plug that in. 8 divided by 2, which is going to give us a value of 4. And we're going to square it. Okay, so we're going to have 16. Now, I need to include 16 in this bracket here. But if I just add this by 16, I'm going to have to add the other side by 16, right? Always when we're balancing equations, whatever we do to one side, we do the other. There's something else we can do. I can add it and subtract it to the same side, which would be essentially just adding or subtracting the value of 0 in here. Okay? So we're going to add and subtract 16 within that bracket. Okay? So our next line will read 2x squared plus 8x. And we're going to add and subtract 16. Now technically, if I just combine positive and negative 16, what am I going to get? 0. So I've really just added 0 to this. I haven't changed anything in the equation. Okay? But the reason we're doing this is, again, remember I talked about we're trying to create a perfect square trinomial? That's essentially what we're going to do. So we're going to take our negative 16 now. So we always take the negative value, and we want to move it outside of the brackets. In order to do that, according to BEDMAS, I have to multiply by the value in front. Okay? Because that 2 needs to be distributed before we can really do any other simplifying outside of the bracket. So when I move this negative 16, I'm going to multiply it by the 2 at the very front, or whatever value that a value was. We're going to get 2 times x squared plus 8x plus 16. And what is negative 16 times 2?
32.
It's negative 32. So we will now have negative 32 outside of the brackets minus 30. Now, I'm going to show you the long way proving that this is a perfect square trinomial, and then I'm going to show you the shortcut, because as long as we've done everything correctly up to this point, we can always use the shortcut. So, I'm going to just put a little side calculation again over here. I'm going to show you the long way, the proof, and then we're going to do a short form in a second.
Wait, is that it?
We're not done yet.
Oh.
So we're going to factor now what's in this bracket. Remember, we've essentially created what is in this bracket. We started, if you recall, with 2x squared plus 16. We took out the 2 value, and then we added and subtracted 16. So I've created this trinomial. There's 3 terms here. I've created this trinomial in the hopes that it's a perfect square trinomial. So we factor. This first value is 1, so we have 1 and 1, and we have 1, 16, 2 and 8, and 4 and 4. Okay? Well, I'm going to tell you very quickly that the 2 values we're going to be multiplying by are both of the 4s, and they're both going to add up to our 8 in this equation. Okay? So in other words, we're going to have x plus 4 times x plus 4 when we factor that. And how can I represent that as one bracket? That's it. X plus 4 squared. Okay? So that's the proof here. And as long, like I said, as long as you do everything up to this point, exactly how I've shown you, you've created a perfect square trinomial. So you don't actually have to factor it this way. What you can do as a shortcut, and I'm going to just move this over here a little. So we have 2x squared plus 8x plus 16. And we still have negative 32 and minus 30. As a shortcut, what you can do is just square root the first and the last term. And those will end up being the first and the last term within our one bracket. So we have our 2. And remember, these, because it's going to be a perfect square trinomial, we can just represent it as one bracket squared. I find the square root of the first term and the last term, and those will be the 2 values. Well, what's the square root of x squared? It's going to be x. Square root of 6? 4. So perfect. We have x and 4, which is exactly like we did when we factored it. And the term or the operation in between completely depends on our b. If this is a positive value, then we bring down a positive value. Had it been negative, we would have brought down a negative value. Okay? And the very last step to this is we simplify those 2 last terms. So we have 2x plus 4 squared minus 62. We've now turned standard form into our vertex form.